What's up, everybody? It's Dan from Sage Math Tutoring and back with another video, this time for an AP Calculus problem that I thought was pretty interesting. So let's dive right into it. The function f is continuous and this equals 6. What is the value of this right here? Obviously, this is a little bit different. We have an x squared minus 1. For everyone watching, including my student who I just worked with, probably we're going to be using u substitution. I think that's probably obvious here. I think the thing to be aware of, though, is an aspect of the fundamental theorem of calculus, and we're just going to remind ourselves of it. And that is the following. So let's remind ourselves that if you are doing this sort of integral here, antiderivative, this is going to be the result of the integral with b substituted in minus the integral with a substituted in. And the a would be this right here, down here. Now, that's something that we should really just keep in mind, because the first piece of information they give us actually is this. And I think it's nice to sort of connect this with that fundamental theorem right now. So we know that according to this information, f of 8, or big F of 8, right, is going to be such that we could write this as well. And then this equals 6. So in other words, anytime we see this, we could replace it with a 6. Okay? Now let's return to that, later. But in the meantime, let's look at this. So we have this thing right here, and we want to know, what does this equal? Well, I think for everyone watching, again, we have a u substitution scenario going on. So we could say u is equal to x squared minus 1. I think that's probably most people's instinct. Then we could say that the du, therefore, is 2x, and then we could say dx. And then I am a fan of them dividing both sides by, in this case, 2x to get that dx by itself. So I'll just kind of do that right here. Obviously, these would cancel. Next thing you know, you have dx equals du over 2x. So I like to always remind myself we have really two pieces of information right now that we just came up with. One piece of information says that anytime you see an x squared minus 1, you could replace it with a u. The other piece of information is that anytime you see a dx, you can replace it with a du over 2x. So therefore, we're going to go ahead and rewrite this thing right now, okay, sort of with that information. So we have a u here. Dx should be du over 2x. And a beautiful thing happens as a result of that. Everyone can see that this x will cancel with this x. And by the way, when doing u substitution, I told my student this earlier today, when doing u substitution, before you pull the trigger on actually performing the integral, there shouldn't be any x's left over. You should have stuff in terms of u only. So this x was sort of problematic. This x was problematic, but now they canceled each other out, and we're good to go, okay? So that is the case there. Now, what are we left with? Well, of course, we are left with this scenario now, and everyone can see, well, we have this pesky 2 that's on the bottom. I think everyone can see that we could extract 1/2 out of the whole thing, and then we would have this, right? We would have this. Now, let's kind of think about this in terms of fundamental theorem of calculus. So it is the case that this would equal 1/2 times a whole thing, okay? Namely, we could say, f of this minus f of something, right? That's what the fundamental theorem of calculus is suggesting. And in this case, we're looking at the big F's. But remember, the u was x squared minus 1, right? Wasn't that the case? And we know that as it pertains to these sort of limits here, we have a 3 and a 1. So hopefully my student is recognizing that ultimately this is kind of like 1/2 big F of something squared minus 1, namely 3 in this case. And that could be minus big F of something squared minus 1, namely 1 in this case. And then we would, of course, be seeing that it's 1/2 times big F of, that would be 8 minus big F of 0. And as we had stated before, anytime we see this structure, that really is equal to 6. Okay, we already established that. So that's going to be 1/2 times 6, and that's going to equal 3, which is the answer. Now, that is kind of long-winded, what I just did there, okay? And I did sort of feel the need to demonstrate that because I want to make clear like what's happening, when it comes to under the hood. What are the mechanics of what just took place there? And this is the mechanics of what just took place. I think the key insightful moment was this, where we realized it's going to be big F of u. Sure, it's big F of u. Big F minus big F of u with these as the limits of integration, but then when you plug it in, it's really x squared minus 1, so we have to do that. Now, another way of approaching these from here on out, so for my student watching, you might just want to realize that that very quickly you could see that, okay, we're going to call u this x squared minus 1, and then du is going to be its own thing. But what you could have done in that moment, okay, from this point forward, maybe this is what you want to do from this point forward, is actually realize that, okay, well, we were given this information as it pertains to f of u, just regular f of u. Well, here's going to be an f of u right here, you know what I mean? But the u in this case is x squared minus 1, so immediately let's adjust these limits right away. We can immediately adjust the limits right away. So the new limits that we'd be dealing with, if we're going to call this f of u, the new limits we'd be dealing with would be nothing more than just making those adjustments right now. The first limit would be this. The second limit would be this. And then you could have sort of immediately cut to, this scenario, okay? Where you have, f of u right here, and then you'd have a du over, I believe, 2x after, doing all of this stuff, right? So hopefully that makes sense. My point is really that, let me just finish this really quick. Yeah. So my point is that you don't have to do all that shenanigans that I did before. I did want to showcase why this works. From here on out, yes, just realize that, okay, if we're going to treat this as u, well, let's adjust these limits right here sort of right away into this scenario because this is the useful scenario, the clearly useful scenario anyway. Okay, and then you would just take it from there, right? Boom, boom. In fact, I'll finish it. Okay. I'll just finish this right now. So this could have immediately have cut to the chase into a 1/2 on the outside here, f of u du, and then we could have realized, oh crap, I know what this thing equals. It's right here. And you could have immediately said 6, right? And that would have spared you all that shenanigans that I did before. Okay? So anyway, that's a tricky one. Kind of weird. Might take getting used to. But anyway, that is how it works.